video. So I need to graph the function f of x equal x squared, x plus 2 over x plus 1. Every time I need to study any function, you need to find first the domain of definition, and from the domain, you do the limits to find the asymptote. What is the domain of this function? It's x not equal to minus 1. So it means it's minus infinity minus 1 and minus 1 plus infinity. And now I need to find the limits. At infinity, as usual, we factorize and then we simplify, we replace. I will have 1 over 1, so 1 at plus and minus infinity, and then the horizontal asymptote will be y equal to 1. When I say horizontal asymptote, guys, it means there is a horizontal line, and at infinity, the function is going to approach to it, it's overlapping it. Then I will do now the limit also at minus 1 minus and minus 1 plus. So when I say minus 1 minus, guys, it means I have a number less than minus 1. So it's minus 1.1. When I'm replacing it in this function, this one will not affect my numerator. Because if I say my 1 plus or 1 minus, in all cases, this is going to be a positive answer. But if I say minus 1 minus plus 1, it's going to be 0 minus. It will give me a negative answer. So plus over minus gives me minus infinity. It's very important to know how to locate the sign here. When I say minus 1 plus, for example, it's minus 0.9. Again, it will not affect my numerator. If it was 1 minus or 1 plus, it's all the time positive, but it will affect my denominator. It's going to give me a positive 0 plus. So plus over plus plus. So I know that x equal to minus 1 is a vertical asymptote. So minus 1 minus, it means I'm here. It's minus infinity, so the function will end here, and 1 minus 1 plus, the function will end here. We will see it on the graph. Now let's graph it. When I say minus 1 minus, we said already, so it's at minus infinity, so it's going to end here. And this one going to end here. And this is my horizontal, so going to go to the horizontal. It cannot touch it. Sometimes in some special cases, it will touch it, but not now. I will take points before the minus 1. So I took, for example, this one. It will give me minus 2, 0. I have minus 3, half. And then it's coming from the horizontal, going to the vertical. Here I have another point. From the vertical to the horizontal. Guys, it's very important to be able to find the intersection. Sorry, x and y intersect. Now let's move to the slant asymptote or oblique asymptote. When I'm doing the limit of a function at infinity and gives me infinity, we say that I have a possibility of an oblique asymptote. Why do we say possibility of an oblique? Because sometimes you will see later on for the exponential sometimes. Even if at infinity gives me infinity, I don't have an oblique asymptote. Sometimes I have it at plus infinity. So, and you need to be careful. I cannot have a horizontal and oblique asymptote at the same time at plus infinity, for example. Either horizontal, either oblique. As a trick for us, when you see that the degree of the numerator is bigger by 1 degree than the denominator, it means that I might have a slant asymptote, or I have a slant or an oblique asymptote. Sorry, guys. Let's do this example. X squared plus 1 over x. First of all, step 1, domain of definition. Denominator not equal to 0. Excellent. Then we do the limits at the open boundaries. At plus and minus infinity, we factorize by highest degree over the highest degree, and then I simplify. I'll get this expression. When I replace it by plus infinity, it's going to give me plus infinity. By minus infinity, it's going to give me minus infinity. It means I have a possibility of an oblique asymptote. Now I will do the limit at 0, and then we will find the oblique asymptote. The limit of a function at 0 plus, it gives me plus infinity, and 0 minus minus infinity. What does it mean? It means that plus 0 plus, it means here the function going to end at plus infinity, and at 0 minus at minus infinity. And x equal to 0, it's the y prime or y, so we're going to graph it later on. How do we find the oblique asymptote? How do we prove it? If I have f of x equal x squared plus 1 over x, when the degree of the numerator is greater by 1 degree of the denominator, I can do the long division. So let's do it. Guys, I will do it from the beginning with you. I just erase this and then I will rewrite everything. So let's remember, how do we do that? We did that in chapter 3, guys, if you remember. So when I'm dividing by x, I need to ask myself, what times x gives me x squared? So it's x times x squared. If you remember, we subtract, it's 0. We take the 1 down, so it's plus 1 here. What times x gives me 1? There's nothing. So the answer is x plus, so this is the answer, plus 1 over x. So y equal x might be the oblique asymptote. How are we going to prove that it's oblique asymptote? Guys, when I say asymptote, it means and I'm graphing the function. At infinity, this function gonna approach to it as it's gonna overlap with it. Okay, it's gonna approach it till the maximum. What does it mean? It will not touch it, but it's gonna approach to it. It means that at infinity, the distance between those gonna tend to be zero. The distance is gonna be zero. So how do we find the distance between two functions or two numbers? We subtract. So this is f of x and this is the oblique asymptote. When I do the subtraction here, it means I'm trying to find the distance between those two functions. If the distance is tending to be zero, it means I can say about this line that it's an oblique asymptote. So that's why we do the limit of the subtraction when x tends to zero, infinity, sorry. When I do the limit, all the time, guys, use this shape of the function. Even if you use the given one, you need to do the same denominator. The x's will cancel each other. You will have limit of 1 over x. Number over infinity, 0. What does it mean? It means that the distance at infinity between the function and this line is tending to be 0. It means that it's an oblique asymptote. Now for the graphing, I will graph first the oblique and the vertical asymptote. The vertical is x equal to 0. It means it's y prime or y. To graph the oblique, you take points, x0, y0, x1 gives me 1. And then, guys, we said at 0 plus, it's plus infinity, so it's going to start from, it's going to end at plus infinity. Here, it's going to end at minus infinity. You can take points before and after. 1 is here, 1 gives me 2, so it's approximately here. So the function is gonna coming to this point and then I go to the oblique asymptote. Minus 1 gives me minus 2. It's from the oblique and going down to the vertical. Guys, when we will do the derivatives, after this lesson, you will be able to understand more the behavior of a function and how I will know that it's increasing or decreasing. You will see that. Now we are doing it approximately, but later on you will understand more how do we graph that. The last thing is the properties. If you have two functions, f and g, and I know that the limit of this function at infinity is L1, and this one gives me an exact number L2, so it gives me an answer, okay? It's an exact number. For example, it gives me 2, 3, 0. So the limit of their sum is the sum of the limits. The answer, the product is L1 times L2. The quotient is L1 over L2. It's a simple property. And even if I'm doing limit of k times f of x, if it's a constant, so I can write also it's k times the limit, so it's k L1. And even if there is an exponent, so it's L1 exponent a over b. That's it for this video. See you in the next video. I will do the limit of the sequences.